Okay, so I am awake at 5 a.m. and couldn't fall asleep too well. On top of which, I've actually been struggling with what the next video is supposed to be. I mean, not that I don't know. I'm insane. I want to do Gaussian elimination. I've just been struggling with actually writing the code myself. I'm gonna like take a quick peek at some pseudocode, and I'm gonna try and do it right now. Just like live behind the scenes. I'm just gonna be mostly quiet, googling stuff and all that. Yeah, that's what this video is gonna be like. Don't even know if I'm gonna actually be able to get the Gaussian elimination done. But let's see. Let's see how this goes. Hoorah! All right. Well, let's post my calendar. You guys don't need to be seeing that. Um, nor my Trello. No, this is what we. Yeah, okay. So that's my tab group. So I know it's here. My problem with the pseudocode isn't that doesn't make sense. It makes a lot of sense actually. My issue is just the edge cases of like, okay, what if it's all zeros? What if it's the last row? How do you like exit out of that appropriately, raising a proper error, or just do it? You know. Um, what is this? Oh yeah, this is my, and this is the one for the recording. Yeah. Okay, so this is for the recording from the last video. Um, for anyone who's watching, I'm not actually trying to solve for the generalized Gaussian elimination where, um, when you have more equations than there are unknowns, or you have fewer equations than there are unknowns. Um, or at least in the fewer equations case, you can parameterize the third unknown in terms of the two unknowns that you can solve using Gaussian elimination, or not solve, but there was an example I read about it. Hmm. So let's go back to that pseudocode. Find the best pivot. Absolute value of AIK, yeah. Set that. Swap the rows, no problem. Okay, I kinda had already done that. Yeah, I went further up and I'm just like deciding to start from scratch again. Well, let's just finally follow the pseudocode, which was Okay. Let's do get call K, comma, A, right? Do that from the column K plus 1. Right? No, I should look at K. Just for that row, whatever, for that column, sorry. Just whatever's the biggest number. Let's just grab that. Right? Because if I do K plus 1, like if I'm looking at a particular column, the next one downwards, I'm only looking at the maximal from the other two. What if I'm already the max? So, okay. Alright, we get the max. The largest item. If P only equals, I'm going to use the walrus operator again just because it's nice. Right. So this loop will never go into the last row, right? Because I'm doing K max minus 1. K max is Leneve. Okay, so I don't need to worry about that. Anyways, in this particular step, P is being assigned to the maximum index. Okay, so then I just want to swap. Swap is in place by the way I wrote it because I just changed the elements around. Swap. K is the current index. P is the new index. Right? A and B. Okay. We swap them. That's our pivot. Pivot's done, yeah? More or less. Swap row, swap. Yeah, that's easy. Okay. There's some other for loop in there, isn't it? And eliminate below. Okay. I'm actually not liking this following the pseudocode thing. I'm just trying to peek and see the first line and try and picture it from my mind. But also this is taking like day and a half for me to try and do hardcore way. Because it's weird, because I can do this on pen and paper, easy peasy. Because, you know, in Gaussian elimination, you just have to eliminate, um, you have to get the upper triangular form and then back substitute to get your actual solutions to the system of equations, right? Um, which isn't a hard process to get to the upper triangular form. So all you're doing is elementary row operations, right? Wherein you're able to attend to each. You can just do it intuitively, like, oh, 3 times this row minus this, that's doable. Obviously not with doable with integers, realistically. But to do this algorithmically so that it just works in every situation is like a little weirdly difficult. For I in range k plus 1, I can do start stop steps, so k plus 1 through till k max, I guess. Okay, so I'm clearing everything out underneath the initial column. Right? Right, this makes sense. There's a secondary loop. Right, I know it looks like I was looking at that pseudocode hard, but I was just like trying to skim it, like be like snip, take a Snapchat. I do this sometimes. I do this often actually, where I'm just trying to take a snap and be like, okay, let me try and get this from the snap when I don't really know, you know. And it's something you don't have the luxury of doing if you're like on bleeding edge of research and stuff or whatever, but you can right now, so at least learn this to someday have the luxury really to even try those kinds of things, right? um, okay, I apologize if there's a lot of background noise. The AC is on. Birds are starting to chirp. It is 5:30 a.m. Fun. I'm having a great start to my morning. I just dissociated for a moment. It's in my head about other stuff. I mean, you guys want to hear something crazy as to why I'm this up? I'm gonna switch the camera to the iPhone one. Let me see if I can move this over here. Yeah, come on. Okay, that's very unflattering. You know, we're just gonna go back to the old way. So the reason I'm awake, I can't stop thinking about this lady I saw at the hospital. My mom's got cancer, so I take her for her chemotherapy, immunotherapy technically, once a week. And I saw this lady, and people are waking up in my household, so this is a story for another time. I'm gonna go back to the video, because I don't want to be talking about that right now. गुड मॉर्निंग अनु दीदी, कैसे हो आप? थोड़ा सोया. Okay, so for iron range K plus 1 through K max. Oh, I didn't switch this back. Let me switch that back. I was like looking at code and you guys were just like staring in my face. I'm gonna look at that pseudocode again. Okay. Define M, the multiplier. Let's not look at the pseudocode anymore. Let's go back up here. But that's right, I'd asked it up. The hell? Why is this pseudocode different than this pseudocode? Because I had a question about partial pivoting. Oh yeah. Okay, no, it's the same. It's the same, except it doesn't have the code for the swap, which I did. It's just forward sub and backward sub. Sorry, forward elimination and back substitution are separated out. Okay. I don't know. Look at that. Let's scroll back up. It may look like I was looking at that pseudocode for a while, but my brain is definitely not processing that well. That's okay. So it's literally just A, I, K, right? I being the row after the current one in this loop, divided by A, K, K, right? Yeah, for the current value, right? See, the thing that's concerning to me about this step and doing this, right, and just doing basically some version of row I, minus equals m times ai. Some bullshit like that. Right? Is what if it's 0? What the fuck? Why am I worried about that? Because if it is 0, I is the element in the next row. So if that row is 0, as long as the current element is not 0, it'll just be 0 or very close to 0. That's actually not a problem, so we should do that. Okay, so that means I equals m times e for e in ai, right? Right. And we do the same with b. Bi equals m times bi, right? Because we have to do the same to both, right? Oh my god, have I just been overcomplicating this and overthinking the zeros? I think I have been. I've been retarded. I've been trying to avoid a divide by 0 error. I'm just fucking stupid. Nah, not stupid, but I'm just being silly. I guess I took way longer on this than needed. And to be fair, I cheated a little bit towards the end. Started just looking at the pseudocode, but this isn't done yet. This is for substitution, isn't it? Yeah. Is that the end of it? You should go through each one. Let's give me a cert to test code I wrote for forward substitution and Gaussian elimination. I mean, we were just burned with this a little while ago. Well, in the very last video. The fuck? These don't seem right. You know what? Let's just do this and Control Enter. I'm just gonna toss all of that. It's a little painful. So I was actually working on that for a while. I thought it'd be more useful. But let's see. We got L3 and B3, F sub L3 and B3. Let's just test this one and see if it makes sense. L3. 5, 6, 7 comes at the top. Yeah. Okay. It's just 0, 0, 0. That I actually don't know what this thing is writing about. Unless I'm misunderstanding the concept of forward substitution, which is possible. Oh, it's forward elimination. Why am I calling forward? Oh, I'm just gonna new chat this. It's forward elimination, and then it's backward substitution. Give me tests for forward elimination, Gaussian elimination. Right, as a search for a Python function. Pure Python function, no numpy. Okay, yeah, I think this would probably, let's hope this generates something that makes more sense, because that last set of things just made no sense. Okay, let's try this. Wait, no. Oh, I accidentally closed my code editor. That was dumb. You know what? Too lazy. Just gonna rename it forward elimination, because that's what it is. Yeah, I figured as much. Yeah, but the problem is A1 itself is changed in my implementation. Let's just get the results of forward elimination A1 B1. A1 4, 3, 1 and 0.5. Wow, okay. Not even close, because this is not even close to upper triangular form, because this expected is actually accurate, right? You multiply the first row by 2, and you do 4 minus that, so that makes sense. Yeah, because I am not doing any subtraction, right? Is this quite correct? Okay, it's not just m times e. That's right. This is where I'm fucking up. It's not just m times e. It's minus equals m times e. it's row I minus m times row k, right? So it's actually not I, it's k. Enumerate a k. So for idx comma e, enumerate ak. And then it's a idx. idx, right? I want to do this in a list comprehension really bad. Oh, Jesus. Okay. I'm gonna throw this to automatic. M times E, right? Because I want to have the multiplier times all the elements of row K, like the top level row if it's the first row or whatever. Minus all of the elements from here. Let's just do AI, and let's start fresh on this. Okay. Right. So I want row I minus m row k, m times row k. So m times row k is m times e in this context, right? M times e. Okay. Hold it command when I mean to hold option. M times e. Okay. Right, row I minus m times row k. I idx minus m times e for idx comma e and enumerate ak equals a. Jesus Christ, that's hard. And same thing with b. We have to correct that. B I minus, yep. Or actually with bi I could just do minus equals and take all of this off. let's see what happens now. 4, 3, 0, and negative 0.5. Does that make sense? It's still an upper triangular form, so that's not bad actually, right? Because we moved 4, 3 up, right? And then we multiplied 4, 3, 4, sorry, by 2 over 4. Yeah, so because k plus 1, which is I, over that, so 2 over 4, right? And took away that, so that's 0, and then that's 2 over 4 times 3, which is 3 times 2, 6, 6 over 4 is like 1, 2, 3, it's 1.5. Okay. Uh, 1.5. 1 minus 1.5 is negative 0.5. Yes, okay, so this actually follows the logic we're trying to do. And it is an upper triangular form, even though it's not the same as this. I think the key distinction is mainly this thing. Right? Which, you know, you could fix by setting this so that as long as it's not 0, just keep moving. Right? I think it's particularly useful to do the absolute when, you know, you're dealing with numbers less than 1 and all that jazz. But this works. Let's see a few of the other examples it's generated. Let's just this scares me. This one scares me. Okay. Let's see. And then forward elimination, A2, B2, A2. 1, 2, 3, 0, 1, 4. 0, 0, 1. Oh shit! No way. Okay, it worked. Oh, it kind of makes sense actually, but still, because obviously, I mean, it's the same revelation I had. Like, if it's already 0, it's not gonna change anything because row k minus equals 0 times row I minus 0 times row k, which is the row above, is like no change to row I, which is like duh, but still. 3 by 3 non-trivial elimination. Ooh. Let's see. Forward elimination, A3, B3, A3. Oof. Okay, so this one we're gonna have to do by hand. 3, 4, 5 moves up top. Makes complete sense, right? And we have 1/3 and 2/3. But the bottom row always comes to 0, 0, 0, so that's good. And 0, 1, 2 Well, not a triangular form. Let me see if I can think about this. It's just a different way of doing it. Right. So 3, 4, 5 comes up top. Okay. And 1, 1, 1 goes to the bottom. Okay. Right. At which point it's 2 times so 3, 4, 5 you'd get 2 times 3 over 2, right, which is 1. 2 times 3 over 2, which is 3, sorry. And then you get 3 minus 3 is 0, so that's this 0 over here. That's fine. Let's see if the 0.33 and 0.6x, which is basically 1/3 and 2/3 with some floating point error shenanigans over there at the end, we go 3, 4, 5, so it's 4 times what? It's 2 times 3 over 2, so it's 4 times 3 over 2, which is 4 and 4 for 2 divided for 3s are 12. 12 divided by 2, 6. Right, 6. Minus 3. 6 minus 3 is something. You know what? I'm gonna kill this video right here. I'm gonna kind of trust this. I'm gonna offline do this, following my algorithm and seeing if I'm getting this. I'm pretty sure I will, but I'll do that offline. I think this is great behind the scenes video. It was fun. And I actually managed to do forward elimination, which is nice. Hopefully back substitution won't be nearly as much of a problem to get the vector x, because that's really the goal, is to get vector x, right? Because that's the whole point of Gaussian elimination. You're trying to solve ax equals b, where a is your matrix of coefficients, x is your vector of unknowns, and b is your vector of constants, right? Yeah. I am super tired. I'm gonna call it for now. This, like, phone camera continuity stuff is insane. Like, bam to bam. Like, you can see all the old on my face. Like, I feel unreasonably old looking at myself right now. Anyways, have a great one. Whoever's watching this whenever in the future.